All right, so I'm going to put up a timer, guys. Good afternoon. Here's our timer to get started on our warm-up. So you guys got 3 minutes. Should be plenty of time. This is just a review of what we did last class. So if you guys have questions, please go ahead and use chat and ask me a question. Good afternoon, everybody. Just come on in and get this warm-up done. We still got 2 minutes left. Good afternoon, everybody. Just make sure we get this warm-up going. Lots of people coming in late. All right. All right, guys, we're going to go ahead and take a look at this review. So as always, if you guys have questions, we will take a look at those. We are doing 9.4 today. That is the tangent ratio. I'm super excited to do that with you guys because it is about trigonometry. Trigonometry. And that is about the understanding of right triangles, circles, and waves in essentially the universe. So we're starting off with some cool stuff today. But before we get to that, let's take a look at this warm-up. So this is what we were working on last class. So again, with right triangles, there is something that only works with right triangles, and that is, hello, welcome. That is, if it's a right triangle, Pythagorean theorem works for it. And that's going to help us out so much because, oh my gosh, guys, you can literally make anything into a right triangle. It is so awesomely powerful. So the first thing we want to do is find the 90-degree angle, and we're going to identify the side opposite of it. We're going to be doing that a lot today. So the side opposite of it is going to be my C. And then that means my other two sides are going to be my A and my B. And it doesn't matter which one's your A and which one's your B because we're adding, so order doesn't matter. So I'm going to go ahead here and go 4 squared plus x squared and then equals my C squared, which is going to be 8. Right? So this is Pythagorean theorem, right? A squared plus B squared equals C squared. So to solve this, remember, we don't want to be doing more work than we need to do. And evaluating these numbers is doing more work than you need. And even if you're like, oh, I can do these in my head, doing them in your head is work. So we want to do as little work as possible. So the first thing we want to recognize is we want to get this x squared by itself. So I'm just going to move that 4 squared over. There's no need to simplify it yet. Okay. Now, please remember, you can't just simplify this. You can't go 8 minus 4, right? Because this is 8 times 8, minus 4 times 4, right? So you can't simplify that. It's multiplication and subtraction. So you can't go 8 minus 4. You can't do that. I'm going to repeat. 4 times 4 is not the same as 8 times 8 minus 4 times 4. So you're just going to keep it as 8 squared minus 4 squared because we're lazy and we don't want to do the work. Okay. Now that I got the squared by itself, the only way to get rid of a square is the square root. So I'm going to square root both sides like this. And when those go away, I'm going to get x equals plus, So I'm going to just, so normally we would do plus or minus. Sorry, in my algebra class, we're doing plus or minus because that's what you're supposed to do. But since here we're finding a length, the negative answer doesn't make any sense. So we don't need the negative answer. So we can go ahead and just get the positive answer. So all I need to do on my calculator is go the square root of 8 squared minus 4 squared. And I'm going to get 4 root 3. Now, again, you guys can use Wolfram Alpha to get those exact answers, right? That's a great calculator to do that. So if you don't have a yellow calculator to give you these exact answers, Wolfram Alpha is how you get exact answers, okay? So again, we talked about that last class in doing the assignment. Wolfram Alpha is a great, amazing website to do exact answers. If we wanted to approximate this answer, right, we would take a look at this. I get 6.928. So I'd look at the 2 to the right of it is 5 or higher. So I'm going to round up. So I get 6.93, right? So you can check your answer if you're using a calculator that doesn't reduce your rational functions for you. But again, Wolfram Alpha is a great calculator. It does everything you need. Okay, so I'm going to hit pause there for a second. Do you guys have any questions or about what we're doing here? Thank you guys for the feedback. Oh my gosh, you're like the first class today where people are actually responding, and I appreciate that so much because, feels like I just talked to myself a lot, you know? All right, thanks guys. So again, if you do have a question, just let me know, and it doesn't need to be, you know, just one person. I'll answer your question. So just please go ahead and ask questions. I want to make sure you guys get how to do this. Okay, so for this next one, when we're classifying, it's kind of the same thing here. We're going to use Pythagorean identity to help us classify it. So in doing that, we always have to identify the largest side, and then the other two sides are going to be our A and our B. So what I'm going to do here is I'm going to say, okay, 5 squared plus 6 squared. I'm not going to write a symbol here, and then I'm going to have 7 squared, because what we're going to do is we're going to compare these squared to 7 squared. So 7 squared is 49. And then using this, I can quickly get 5 squared plus 6 squared. So that is 61. Okay. And then remember, we're always looking at the hypotenuse. The hypotenuse has the coolest name. We're checking out the hypotenuse. So we want to know first, are they equal? No, they're not equal. So it's not a right triangle. So the next thing we want to say is the hypotenuse bigger or smaller? And in this case, it looks like it is smaller. So if the hypotenuse is smaller, then we're going to get an acute triangle. Okay. So before we move on today, does anybody have questions about those two things that we did last class? And remember, if you guys have questions, please go ahead and just interrupt, ask a question, because you getting this is more important than me just talking. Okay? All right. So let's go and take a look at what we're doing today. So again, really super excited what we're doing today. So we're going to be, if you're following along in the book, we're doing 9.4, and we're going to be talking about the tangent ratio. Now, before we get into the tangent ratio, though, I have to make sure you guys understand conceptually what is going on here. Okay, so there's a couple of different things we're going to look at. So the first is this relationship between angles and the opposite sides. Okay, so I'm going to draw a right triangle like this. Now, looking at this right triangle, we've already dabbled a bit into this idea of there being a relationship between an angle and the side opposite of it. So first of all, the 90 degree is the biggest angle. Okay, so in a right triangle, the 90 degree is always going to be the biggest angle. And then we said, well, if we know what the biggest angle is, then this has to be the biggest side. Okay, so that's what we worked on last class, right? We know which one is our hypotenuse by knowing which one is our 90 degree angle. Okay, so the biggest angle is across from the biggest side and vice versa. Okay, but we're going to take that one step farther today and see that there's this really cool relationship. In fact, there's several cool relationships with right triangles. And that says, okay, let's say this is the smallest angle. So if this is the smallest angle in the triangle, then that would imply that the side furthest away is the smallest. Okay, so if the biggest angle is across from the biggest side, then the smallest angle has to be across from the smallest side. So this is where I'm going to have you guys, I need you guys to have a little imagination. What's going to happen to this side if this angle gets smaller? So if this angle gets smaller, can you imagine squishing this closer and closer together? What's going to happen to this side? Can you guys type it into chat? So this angle down here is going to get smaller. What's going to happen to this side? Right? So again, this angle down here is going to get smaller. What's going to happen to this far side? So I need you guys to respond in chat. So if this angle here, you can even take your fingers, right? And think, hey, if this angle gets smaller like this, right? You can even go like this and kind of like, if it gets smaller, what's going to happen to the sides? Right? So let's see. I'm going to try to do it with 2 pens. I'm going to have to go like this, like chopsticks. So I have 2 sides. It's what happens if the angle gets smaller. Do you guys see that? What happens if the angle gets smaller? Right, so this far side, do you guys see how it's between the 2 pen tips? So if that angle gets smaller, doesn't the distance between the pen tips get smaller? Yeah. And so so that's the relationship we're going to be looking at today. If this angle gets smaller, this side is going to get smaller. Well, what happens if this angle gets bigger? Right? So we can take a look at the same thing. Let's see if I can do this now. So what happens if that angle gets bigger? So if that angle gets bigger, do you see how that side's going to get bigger? Okay. So if it gets smaller, then that side gets smaller. If the angle gets bigger, then that side is going to get bigger. Okay. So there's this relationship with these other angles, the acute angles. As this angle gets bigger, the opposite side gets bigger. Okay. And you're going to want to check out this this lesson on YouTube then. And as this angle gets smaller, this side's going to get smaller. Okay, so as the angle changes, this side changes. Well, it turns out it's a little bit more complicated than that, because not only is this angle connected to this side, but what about this other angle here? So let me draw another triangle and help explain this. So before we get into this, I'm going to teach you guys 2 Greek letters. Okay, the first one is a circle with a horizontal line through it. This is a Greek letter called theta. Theta, not theta. Theta. It's theta. Like they, ta, theta, theta. And theta. Okay, this is the Greek letter theta. And we use this instead of x and y to denote angles. Okay. Now another one that we're going to be using is a vertical line through this, and this is called phi. Okay, it's called phi, the Greek letter phi. Now, that's how Americans say this, right? So this is American English. If you were British, you would say theta and phi. Okay, like phi, phi, fo, fum, right? But we're in a USA, so we say theta and phi. Okay. So let's take a look at a different triangle. So I'm going to make a different right triangle, and I'm going to explain this relationship. Okay. So let's say I have triangle ABC, where C is the 90-degree angle. Okay, and then I'm going to call angle A, I'm going to call that theta. So theta represents some unknown angle. So I use that instead of x or y. So that way when I put theta, you guys know I'm talking about an angle and not a side. Okay, I can even put degrees on it, right? So theta degrees. Now, we're looking at this triangle and we want to figure out relationships holistically. So what do the angles in a triangle add up to? Can you guys tell me in chat, what do these three angles add up to in any triangle? 180, right? So what we're saying is angle A plus angle B plus angle C equals 180 degrees. Okay. Well, what we can do, since we named one of our angles, I can replace angle A with theta. We don't know what angle B is, and angle C is 90 degrees. Okay. So what I'm going to do first is I'm going to subtract 90 degrees from both sides. Okay. So I got theta plus angle B equals 90 degrees. Now notice here, right? I can now have the opportunity to solve for angle B. So to do that, I'm going to subtract theta from both sides. So I end up with angle B equals 90 degrees minus theta. So right here, I can write this angle up here is 90 minus theta, and that's this angle right there. So this angle right up here is 90 degrees minus theta. Now, why did I do this? You're like, crap, you're taking us down this dark, scary alleyway, and we don't have flashlights. Well, let me give you a little flashlight onto why we're doing this. Because we said if this angle theta gets smaller, then side BC is going to get smaller, right? And if angle theta gets bigger, then this side BC is going to get bigger. Well, what's really interesting about this is check this out. So let's say theta gets smaller. Well, then this side gets smaller. But now we're going 90 minus something smaller. So this angle is going to be bigger. So as this angle gets smaller, this angle has to get bigger because they have to add up to 180 degrees. So if one angle is getting smaller, the other angle is getting bigger. So if one side is getting smaller, the other side is getting bigger. So we have this relationship of angles where the angles have to add up to 180. One of the angles is going to be 90, right? Always. And so we have this relationship where if one of the acute angles goes up, the other one has to go down. Or if the other one goes down, the other one has to go up, right? So they're inversely proportional. As one goes up, the other one goes down. Well, it turns out then that if this relationship holds, that as an angle decreases, the side decreases, and that means this angle would increase and this side would increase, that means there is a relationship in the sides. And these relationships are captured in trigonometry. What? Trigonometry. And that is the study of how right triangles are circles, are waves, which is the understanding of the universe. Okay, and it starts right here. The idea that these angles have a relationship and they share that with the sides. And that's what we're going to be learning about today. We're going to be learning about a whole new function, because look at this theta. Theta can be anywhere between 0 degrees and 90 degrees. And how many degrees are in between? An infinite amount of degrees. Right? Because like it could be 0.1111111111111111111, and the next one could be 0.11111111112. Right? So there's an infinite amount of angles that can be in here, which means there's an infinite amount of ratios that exist in these triangles. So what we are setting up is we're going to have a function based off an angle that gives us ratios of sides. And that's what trigonometry, that's essentially what trigonometry is all about. Okay, so this is what we're going to be learning today, is this ratio with this relationship. And I hope this makes sense in a little bit, because I want you guys to understand what we're doing. Okay, so the first thing, so before we get to tangent ratio, the first thing we have to get good is naming sides. Okay, and to name sides, we're going to have something called a reference angle. Okay, now you might have heard of the word reference before. So not reference as like you need a reference to apply for a job. This is going to be reference in the sense that people have a different frame of reference. So for example, if everyone in this class sees this class differently, right? Some of you are on a Chromebook. Some of you might be on a phone, right? I see one of you on a phone. Some of you might be on a desktop, right? Everyone is going to see this class slightly different because everyone has a slightly different frame of reference. Well, in a triangle, there are two frames of reference. So we're going to need to know what our reference angle is going to be. So for example, let's say I have a right triangle. I'm going to make it a little bit bigger. Okay. Oop, a right triangle. I should make it a right triangle. There we go. And this right here is going to be my reference angle. Okay. So a reference angle is, let me write this in black. A reference angle is the angle we pick to look at the triangle. And it must be acute. So we're never going to pick the 90-degree angle as our reference angle. So it's the angle we pick to look at the triangle. It must be acute. Okay? So for us right now, the reference angle that we're picking is theta, that blue theta. Okay? This is our reference angle. We're going to look at this triangle from the eyes of that theta. So this is how you name. So we're going to name this triangle based off of our reference angle. So I'm going to give you 3 steps because there's 3 sides. First, always, and guys, I'm not making this list because it's cute. You have to follow this. Always identify the hypotenuse first. Always, 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 always. Always identify the hypotenuse first because the 90 is never going to change. We're only looking at right triangles. So always identify the hypotenuse first. Always identify that first. Okay? So the first thing I do is I write my hypotenuse. Okay? Step 2. Okay? Always find your hypotenuse first. Then find the opposite side of your reference angle. And I'm not joking, guys. You have to do it in this order or mistakes are going to be made and you're going to be like, oh man, Kreft warned me. Find the opposite side of your reference angle. So my reference angle here is in blue. So the opposite, another way of saying opposite, is furthest away. So the side furthest away from my reference angle is all the way over here. This is my opposite. Okay. Then the last thing you can do is the last side is your adjacent side. So the last side is your adjacent side. Now, why do we do adjacent last? Because if you look at this reference angle, right, there's actually two sides that are next to it because adjacent means next to. So if you don't label your hypotenuse first, you could accidentally call your hypotenuse the adjacent side because it's next to it. So always do your adjacent side last. Always do your adjacent side last, and then you will avoid that confusion. You will avoid that confusion. Okay, so why did I make a big deal about this? Well, that's if we use theta as our reference angle. What if I go up here now and I pick a different color and I call this angle phi? Well, phi is going to have a different perspective. Now, notice, we identified the hypotenuse first. Because even to phi, this is still the hypotenuse, right? The hypotenuse is based off the 90, and the 90 hasn't changed. But what has changed? Well, now what's changed is what's opposite. According to phi, the opposite is down here. Do you guys see that? So depending on what your reference angle, opposite is defined as being the furthest away. So then this one would be adjacent for black. Okay, so depending on what your reference angle is what the side is called. Okay, and we're going to go ahead and practice 2 of these. And I really think after doing 2 of these, you guys, we can figure it out. Okay, so let's practice naming some things. You always want to identify the hypotenuse first. Then find the opposite side of your reference angle. What's ever left over is adjacent. Okay, so let's go ahead and practice doing this. Okay, so naming sides. Name the sides. So the first one here, we're going to have a right triangle. And this is my reference angle. And then the second one, we're going to have a right triangle. And this is my reference angle. So I'm going to give you guys 1 minute to look at these 2 triangles. And just label the sides, hypotenuse, opposite, and adjacent, right? And I want you to do it from the reference angle I have highlighted. So you're just labeling the sides with respect to the reference angle. All right, so let's take a look at these 2 problems. And hey guys, mistakes are going to happen, and that's the whole point of this. So if you're making mistakes or you're frustrated, don't be frustrated, right? Frustrated just means you're trying, right? So if you're frustrated, that's really good, right? That means you're trying and you're just stuck. So let's get you unstuck. So the first thing we always do is the side furthest away from the 90. That's our hypotenuse. Okay, so the side across from the 90, that's the hypotenuse. Then you take a look at your reference angle, and then you take a look at the side furthest away, and that is the, opposite side. Yep, so just remember, yeah, you're going to have to put in the work later, looking at the YouTube video. Okay, so I have opposite, and then I have the hypotenuse, and then the last one we do is the adjacent. Okay, so opposite, hypotenuse, adjacent. Okay, and let me know if you guys have questions. Okay, I come over here. So the first thing I should always look for is the side across from the 90. Now, if you guys want really cool shorthand, you can just do the first 3 letters. So we can do HYP, or hype, for hypotenuse. So across from the 90 is our hype. Furthest away from our reference angle is our opposite, or OPP. And then the last one is adjacent. Just if we use ADJ, we have to remember that it's not adjective, right? That's English. This is adjacent, or next to. Okay. How did we do there, guys? Because this is really important. We can't do trigonometry unless we can identify sides based on the reference angle. So are we doing okay? Do we need more practice? Where are we feeling with this, guys? Okay, so just remember the order. Do hypotenuse, opposite, then adjacent. And if you do it in that order, you're going to have a lot less problems. Okay, I can't say you're not going to have any, but you're going to have a lot less. So hypotenuse, opposite, adjacent. All right, it's like, well, we haven't talked about tangent yet, so we had to do all this build up for tangent. So now let's talk about tangent. So the tangent ratio. Now remember, the tangent ratio is a ratio means a fraction. We're going to be comparing sides, right? And the ratio of sides is going to be dependent on an angle. So this is actually a function, and it's a function that's on your calculator. So see on my calculator how I have tangent, just like I have x squared. So tangent is a function just like x squared is a function. Kind of cool, right? Okay, so tangent is a function. And I'll show you guys how to do this on Desmos, and I'll show you how to do this on a yellow calculator. And always remember, if you guys want a yellow calculator, that they're available to check out at the school library. Okay, so the tangent ratio is this. The tangent ratio is, we shorten tangent to tan, but you never say tan. You say tangent. Tangent of theta equals the ratio of opposite over adjacent. Okay, and let me break this down for you guys, okay? So the tan means tangent. The theta is our reference angle. Okay, and opposite and adjacent refer to the sides to the reference angle. So the opposite is the side furthest away from our reference angle, and adjacent's the one next to it that's not the hypotenuse. Okay, so we say this as tangent of theta equals opposite over adjacent, and this is a function. Okay, now before we get into the function part of this, you guys have this down. This is the tangent ratio. The first thing we're going to do is just practice finding the ratio. Okay, we're not going to use the function. We'll do that in a little bit. But first, let's just practice writing the tangent ratio. Okay, so let's take an example of this. Okay, so an example of this, let's say we have a nice big right triangle. Let's say STR, And let's call this side 82, 18, and 80. Probably not drawn to scale. Okay, so get that down really quickly. Now, as you're getting this down, think to yourself, okay, there's two acute angles, which means there's two possible reference angles we can use. Those two angles are angle S and angle R. So the first thing I might ask is, all right, so what is the tangent ratio of angle S? Right, so that's going to be a ratio. It's going to be something over something. So we have to remember, right, that a tangent, so tangent of a reference angle is the opposite side over the adjacent side. So if I'm looking at this, well, the hypotenuse is 82. So the side furthest away, the side opposite of angle S is 80. And the side adjacent to angle S is 18. Okay, so that is how you write the ratio of tangent of S. So tangent of angle S would be opposite over adjacent. For right now, that's the answer. Okay, this is just, again, this is just basic doing this. Now, you can simplify this. So remember, Desmos and and yellow calculators will simplify this. So for example, if I go 80 divided by 18, the calculator will automatically reduce it. So 49ths is the better answer, right? Because that's simplified. Okay, so this is simplified. And Desmos and your calculator will do this for you. All you have to do is just type it in and it will do it for you. Here, and I can, if you guys want, I can do that really quickly. I can take you there. Okay, so I can just type in 80 divided by, what did I say, 18? And then click this button and it will do 49ths. Okay? I'm gonna hide that for a little bit. All right, so then, but now what if we change reference angle? So what if I say tangent of angle R, right? So that's going to change my ratio. So it's still going to be a ratio, but the opposite of angle R is now 18, which means the adjacent is 80. So that would simplify to 9/40ths. Okay, so again, all we're doing here is practicing writing the ratio. We haven't got to the function part yet. Okay, so we're just writing the ratio. We're getting used to, given a reference angle, finding the ratio. Okay, that's what this activity is right now. So I'm going to have you guys, if anybody doesn't have any questions, I'm going to have you guys try this on your own. Okay, so I'm going to have you try on your own. Okay, so let's get a new triangle here. There's a new triangle in town, partner. Okay. Okay, so I'm going to label some stuff. And then I'm going to say, I want you to find tangent of angle A and tangent of angle B. And all you're doing is you're finding the ratio. And I'm going to give you guys a minute to do that. Okay, so all we're doing is we're finding the tangent ratio. So we're just filling out the ratio part. We're not solving for anything, just finding the ratio. All right, sorry, it's a minute. I was responding to people in chat. Thank you guys for communicating. I appreciate that. So tangent of A, right? So first I say, okay, my hypotenuse, right? That's across from my 90-degree angle. So tangent here is going to be opposite. So opposite of A is 15. And then adjacent would be 36. Now remember, I can simply, oops, I just want to move you. I can simply type that into my calculator. So I can type in, what's on top? 15, oops, and oops, that doesn't do it either. How about let's do this? 15 over 36. So it's really easy to do. So I can get 5/12. Oops, everything I'm writing is behind it. There we go. So I can get 5/12. Okay. Tangent of B would be opposite now is 36 and adjacent now is 15. And since I've already reduced this one, I know it's going to be 12/5, right? It's the same numbers. Okay, does anybody have questions about that before we move into solving and using the function format, right? So this was just, can we set up the ratio? Does anybody have questions or comments or concerns? So we do want to simplify it because it's easy to do because your calculator can do it for you. So if your calculator can do it for you, then I'm going to expect that you do it, right? It's not that much more work. It's just like click, 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 click. Maybe too many clicks. That was too many clicks. All right. Are we okay, guys? Yeah. All right. Cool. Let's take a look at some more problems then. Let's take a look together. All right, so what we're gonna do now is like the real deal. Man, I've been really building you guys up for this, haven't I? Right? I've been really building people up. So what we're gonna do now is, now that we have all the building blocks, we're going to use this to start finding missing sides with tangent. Okay, now this isn't the only thing we can do with tangent, but it's a really good starting point. There's lots of things we can do with tangent. So let's do an example. I'm going to do 2 examples with you, and then we're going to have you guys try one on your own. Okay, so the first, I'm going to start by drawing a right triangle. And I'm going to have 32 degrees, 11, and X. And I'm not going to label anything because I don't need to. Okay. So let's go through step by step what I'm going to do. So the first thing that I want to do is I want to label all sides. Okay. So I'm going to label it. So the first thing I do, across from the 90, that's my hypotenuse. The furthest away from my reference angle, that's my opposite. And then the only one that's left over is adjacent. Okay, so always start by labeling all your sides. And how do we label it? Hypotenuse, opposite, then adjacent. Okay, step 2. We're going to write our tangent equation. Okay, so we're going to write our tangent equation. So I know tangent is opposite over adjacent. So this is where we're going to get into the function part of this. So tangent of my reference angle, so that means tangent of 32 degrees, equals my opposite is 11 and my adjacent is X. Okay, so just a reminder, right? This is opposite, this is adjacent, this is my reference angle. Now, before I go any further, people freak out when they see something that is not something they've seen out before, and they're like, I can't do algebra with that. Guys, you could do algebra with anything. I could draw a picture with frogs and pineapples, and we could do algebra with it, right? That's the beauty of algebra. Think about numbers. Numbers are made up, right? Humans made numbers up just like letters. They're just totally made up, right? You're just used to seeing them. So when you see tangent of 32, you can't be like, oh, I don't know what to do. Okay, first of all, just to help you guys out, I want you to know that tangent of 32, this is a number. And to show you, and make sure if you're using a physical calculator that you're in degrees, it will say DEG at the top. And then on Desmos, it says DEG right in the middle. Okay? And if you type in tangent of 32, I get this really, really ugly number. Really ugly number. It's irrational. It goes on forever. Okay, so just right here, I want you guys to know tangent of 32 is a number. And you know what? If this is a number, that it's just like it would be if this was 7. Right? And we can do whatever we want with 7, right? We can add it to both sides. We can subtract it, multiply it, divide it. Okay, tangent of 32 is just a number. And it's such an ugly number that we'd rather just write it as tangent of 32. Okay, again, being lazy is fun, right? So we don't want the trouble of having all that ugliness. So tangent of 32 is a number. We can do it with it just like anything with algebra. So our third step is to solve for x. Okay, now, every year, and I know you guys aren't, like some of you guys aren't going to listen to me, okay? And it just is what it is. I've come to accept it. But I'm going to say it anyways because a lot of you will listen to me. Do not memorize how to solve this. Oh my gosh. And every year I get kids who just memorize the steps, and then they get to a couple of classes down the road. They're like, I don't know how to solve this. I tried my memorized steps. Well, don't memorize this. There's nothing to memorize. Okay? When I say solve for x, this is just like any other time you solve for x. So if I want to solve for x, do you guys see how I have x on the bottom on this side? Do you ever want x on the bottom when you're solving? Is that our end game? Right? Do we want x on the bottom? No, we don't want x on the bottom. So get x off the bottom. This is 11 divided by x. So what's the opposite of divide? It's multiply. So let's multiply both sides by x. Okay, the x's go away. And I get x times the tangent of 32 degrees equals 11. Okay, now remember, tangent of 32 is a number. So I want to get x by itself, right? Well, I got it off the bottom. That's good. But it's still not by itself. So like this could be like 7x, right? Tangent of 32 is a number. How would you get rid of multiplication? Of course you know that answer. To get rid of multiplication, you would divide by tangent of 32. Right? Because anything divided by itself is 1. So I get x equals 11 over tangent of 32 degrees. So all you have to do now is put this in a calculator. Right? So this is our exact answer, right? This is our exact answer. So since a lot of people are using Desmos, I'm going to go ahead and use Desmos for this. Okay, so how do you do this on Desmos? Well, to use this on Desmos, what I would do is start with a fraction. On top, I would have 11. And then on the bottom, I would put tangent of 32. And there's my answer. So again, this is not an exact answer. So I would do is approximately, and then I would say 17.60. Okay. Does anybody have questions on how I did that in the calculator? And it looks like we're running short on time, so I might not get to a practice problem that you guys try on your own today. We might just take notes and do some practice tomorrow. Gosh, it's really windy outside. Cray cray. Totes cray. All right, no one's asking any questions. Well, let's do one more example. And this example is to show why you shouldn't memorize how to solve something. You should always just do the algebra. Okay, so this next one, we're going to draw one more triangle. I know I'm running short on time, so we're gonna make it lickety split. So let's say this is 25 degrees up there. This is 12, and this is x, and we're gonna solve for x. Because that's where I hid my treasure. No, seriously though, I lost my treasure. Okay, so let's communicate. Let's talk out, right? We're in this together. Let's talk this out. What's the first thing that we're gonna do? We're going to label the sides. So across from my 90 is my hypotenuse. The side furthest away from my angle is my opposite. And then I do my adjacent last. And what that's gonna do is that's gonna allow me to write my tangent ratio. I'm gonna write tangent of my reference angle equals opposite over adjacent. Okay, so I have tangent of my reference angle equals the opposite over adjacent. And I'm going to just write that down again because this is new and it's always good to overdo it with new things. Okay, now to solve this, this is going to be different than solving the other one, which is why you don't memorize how to solve these, because there's lots of different scenarios that come up. And so memorizing it won't help you. Okay, because we're just starting in trig, right? There's so much more to this, and there's so many different possible things. So all you have to do is figure out, okay, where's my x? My x is on top. That's really good. I want my x on top. But what I don't want is I don't want this divide by 12. So how do we undo divide by 12? Well, we multiply. So I'm going to multiply both sides by 12. Okay, and I get 12 times the tangent of 25 degrees equals x. And that's it. Okay, so that's really nice and easy. This is my exact answer. Okay, but if I pull up my calculator again, I moved my time. If I pull up my calculator again, so this time I'm just going to have 12 times tangent of 25 degrees. And then, so this is approximately, what do I have here? Ooh, this is a really interesting one, right? Because I'm going to have to do some serious rounding. So I just want to show you guys. If I go here to the second decimal, it's a 9, but the one to the right is a 5. So I have to round that 9 up. But what does 9 become? 10. So I really round up that 5. So what I'm going to write here is 5.60. And it's important that I include that second decimal because that's where I rounded to. I rounded to that second decimal. All right, so unfortunately, we didn't have time for you guys to do a practice problem, and I'm sorry that's the way it happened. But tomorrow, we'll start off class with you guys doing a couple of practice problems to get you guys feeling comfortable before you get started on your assignment, okay? So I know a lot of you guys are on campus and you need a couple of minutes to pack up. Let's do that. If you're at home, thank you guys. I really appreciate all of you. Remember, I have office hours from 8:30 to 10 in the morning. So make sure if you guys need help to come and ask questions. I want to help you. I want you guys to be successful, okay? All right, bye everybody.